sometimes we'll need to use properties of logarithms to solve a logarithmic equation. So in this case, what I'll do first is use the property that says if I have a coefficient, I can always swing that back to become an exponent. So I'm going to do that to begin this problem. What I notice now is that both sides have a single logarithm, log base 3. Since they both have just a single logarithm and it's the same on both sides, I'm going to go ahead and just cancel that part out and ignore it. So all that's left over is this equation, x squared equals 121. Since the log bases are already the same, all I have to do is worry about making this part the same. Well, from here I'll solve this quadratic equation by taking a square root of either side. So I end up with two answers, remember, when I take a square root when I'm solving. I get x equals plus or minus 11, positive 11 and negative 11. Well, even though that's the solution to that quadratic, remember it also has to check out when I plug it back into the original equation. And recall that we cannot do the logarithm of 0 or anything negative. So what we plug back in cannot make this part of your logarithm 0 or negative. Well, that becomes very clear then, or it becomes very clear that negative 11 isn't going to work because I'd be doing the log of a negative number. What I'd say is that negative 11 is an extraneous solution. So even though it's a solution to the quadratic, it does not work in the original problem. Therefore, my only answer is positive 11. Negative 11 is extraneous, it does not work. And here's one more example of how I can use properties of logarithms to solve a logarithmic equation. This time I have the same log on both sides, natural log, but this side has two of them. So what I'll need to do is condense this into a single logarithm. Well, good thing we know how to do that. Because those two pieces are being added together, I can condense them using multiplication. This 3 right here will multiply by the x plus 5 over here. That was one of our properties of logarithms. And so when I condense this, I'll go ahead and just distribute the 3, I'd end up with the natural log of 3x plus 15 once I distribute and make a single logarithm. Well, the other side will leave as is. It was just natural log of 2x. And like our last example, what I'm noticing now is I have the same exact thing on both sides. I have natural log. So I'll cancel that out. I'll ignore it. And I'll just worry about making 2x equal to 3x plus 15. When I solve this equation, I can subtract that 3x and get negative x equals 15, and then divide by negative 1, so I get an answer, an x value of negative 15. Well, recall, I'm not allowed to take the logarithm of something negative or 0. So take a look at what your x is and see what would happen if you plugged it back in to the original equation. If anywhere you plug it back in would end up with, you'd end up taking the log of something negative or 0, you can't use that solution. And it becomes pretty clear that if I plugged in negative 15 for x, I'd be doing the natural log of negative 30, and I can't do that. You can't do the log of something negative or 0. So my only solution I get is an extraneous solution, which means the answer to this question is there is no answer. Since the only thing that actually could have worked was extraneous, all I can say is that this problem has no solution. There's no value of x that will work in this equation.